Now let's go back to the current weather component and update this to use our row text component. So I'll start by adding row text just before the view with the high-low wrapper. Next, I'll set up our props. So I'll say message 1, and I'll set this to high, colon, 8. Next, I'll say message 2, and I'll set this equal to low, colon, 6. I'll set container styles to styles dot high low wrapper, and then I'll set message 1 styles to styles dot high low, and message 2 styles to styles dot high low. Now I can go ahead and delete the existing view and text here. Next, above the view with the body wrapper, I can follow these steps again. So I add the row text, and then I set up my props. So I say message 1 and set this to it's sunny. Next, I set message 2 and I set this to it's perfect t-shirt weather. I then set container styles and set this to be styles dot body wrapper. And then I set message 1 styles to styles dot description, and message 2 styles to styles dot message. Now I can go ahead and delete the existing view and text here too. We need to make sure the row text component has been imported at the top of the file. VS Code has done this automatically for me when I started using the component. Next, let's go back to our app.js file, and in the render, let's update this to show the current weather component. Now let's run the app in the simulator and see how everything looks. When the app runs in the simulator, it looks like something's broken. Debugging errors is a really important process to get to grips with when you're working with your code. Sometimes it's just figuring out how to approach a problem, as opposed to panicking. So how do we know what the problem is here? Well, we know the only components we have changed are the city and row text components. It's the row text component which is not showing on our screen, so let's take a look at that first. The render looks okay, but when we destructured our props, I set this to styles, not props. So this looks like it will be the cause of our problems here. I'll change this from styles to props. Also, we aren't setting anything in our style sheet, so let's clean this up too. I'll remove the style declaration, and I'll also remove style sheet from the imports, as it turned out we didn't need this after all. Let's save this and view the app in the simulator. Everything now looks good. Let's wrap up our refactoring by just doing one last bit of cleanup in the current weather component. For consistency, I'm going to add destructuring to the styles used here. So I'll say const, then I'll use some curly braces, and then I'll say equals styles. Inside the curly braces, I'll say wrapper, container, temp, feels, high-low wrapper, high-low, body wrapper, description, and message. Then I'll go ahead and remove the styles and dots inside of the render function. Let's save this and run the app in the simulator again. Now everything looks good and we have fixed the issue with the row layout not displaying. So now we're ready to go ahead and look at wiring up our app with navigation. When you're building web apps, you can use anchor tags to link between the different pages. If a user clicks on a link or a button to navigate to a new page, then that URL gets pushed onto a stack, which is essentially a data structure, and in this case it will be called the browser history stack. Later, when the user wants to navigate back, then the URL gets popped off the stack, and they're able to go back to the prior page where they'd come from. When you use a mobile app, it's quite unusual these days that it will only have one screen, as they usually have more information to show a user. However, we can't use navigation in the way that we do on the web, so we need some way to navigate between the different screens in our application. In our app, we have already built 3 different screens. We have a screen to show the current weather, a screen to show the upcoming weather, and a screen to show the city details. In order to navigate between the screens, we need to use a navigator. You might have noticed this before, but the other consideration with navigation is how the navigation between the screens occurs. So by this, I mean the transition. When you click something in an app to load another screen, does the next screen then slide in from the right to the left? Or does it perhaps drop down from the top to the bottom? As well as all of this, there's then the different types of navigation to consider, because perhaps we want to use tabs in the app to let the user navigate around. In React Native, there's no built-in navigation, so you have to use a library to add navigation to your app. The 2 most popular libraries are React Navigation and React Native Navigation. While both of these libraries have the same end goal, the implementation of the 2 differs. The other consideration between the 2 libraries is that React Navigation is built into Expo. So if you created your app with Expo, you can use it just fine. However, if you want to use React Native Navigation, you would have to eject your app from Expo, or you would have had to create your app without using Expo, and I showed you how to do this at the start of the course. So in our app, we're going to be using React Navigation, and our goal is to implement tabs for the user to navigate between our different screens. So let's start by installing React Navigation. To do this, in the terminal, we need to type npm install @react navigation /native. Next, because we're using Expo, we have some additional dependencies we need to install to get everything up and running. If you're not using Expo, you can see the additional installation steps required to get up and running with React Navigation here. So for Expo, we need to run npx expo install React, dash, native, dash, screens. React, dash, native, dash, safe, dash, area, dash, context. So once everything is installed, we need to set up a navigation container. This will wrap the entire application, and usually we'd only do this once in the application, and we do it at the root of our project. So we're going to add this to the app.js file. So we start at the top of the file and we say import. Next, we use curly braces. And we need to make sure we use a capital N. And we say navigation container. And this is imported from @react -navigation /native. Next, inside the render, at the top, we need to place a navigation container. Then we close this at the very bottom of the render so that it contains everything. At the start of this section, I discussed how, on the web, we push and pop items off of a stack. With React Navigation, we follow a similar idea, except that we do this via a navigator. So the screens can get pushed and popped off of the navigator. There are two types of navigators we can use, and this depends on our requirements. Essentially, if we don't want the user to navigate to a screen using a tab, then probably we'll want to use the stack navigator. So let's look at some examples to show this a bit more clearly. If I load this example on Snack from the React Navigation website, I see a settings screen. If I click the button that says Go to Profile, I'm then navigated to the profile screen. Next, if I then click the back icon, the profile screen is popped off of the navigation stack, and I'm back on the settings screen. For this kind of navigation, you would want to use a stack navigator. At the bottom of the screen, there are also some tabs. When I select one of these, the screen the user sees changes, and this is the behaviour I want for our application. If you want to explore more deeply all the kinds of navigation available to use with React Navigation, then you can visit this GitHub repository. And then you can navigate to the example section. If you load this, then you can play about with everything. So for our app, as I said, we want to use tabs to let the user navigate between the different screens. It's up to you when you create your app to decide where you want the tabs to show, as you can show them on the bottom of the screen or the top of the screen. There are some platform considerations to bear in mind here too, as often on Android, you have tabs at the top of the screen, and on iOS you have them at the bottom. In our app, we're going to display the tabs at the bottom of the screen. But if you wanted to show this on the top for Android and the bottom for iOS, you would need to set up material top tabs, and then decide which to display based on the platform. You can access the platform the user is using by using the Platform API from React Native, and then you can use the OS property. So back to our tabs. We need to start by installing the bottom tabs. So we say npm install @React Navigation /bottom tabs. Once this is done, if we go back to our app.js file, we can import this. So underneath the import for the navigation container, we say import, then we use curly braces, and inside the curly braces, we say create bottom tab navigator. And then we say from @React Navigation / bottom tabs. Next, before the component is defined, we need to say const. Then using a capital T, we say tab equals, and then we say create bottom tab navigator, and follow this with parentheses. By doing this, we're initializing the tab object so that we can use it. Next, we want to wrap all our components inside of the tab navigator. So inside the navigation container, we say tab dot navigator. And then we close this just before the closing navigation container. So next, we're ready to go ahead and add our screens. So I say tab dot screen. And then I set the component name. So I say name equals, and as a string, I add the component name. And so the first one for us will be current. And next I add the component. So I say component equals, and then I'll set this to current weather. Then I repeat this again for the other two screens. So I say tab dot screen. And then I set the component name, which is upcoming. And I set the component to upcoming weather. Lastly, I say tab dot screen, and this time I set the name to be city. And I also set the component to be city. So now we should have just set up the 3 screens for our app. Let's save this and see what things are looking like in the simulator. When the simulator runs the app, we see a screen with an error. The error says, a screen can only contain screen, group, or React fragment as its direct children. So clearly we made an error here. The only file we've changed directly is the app.js file. So let's go back to that file and take a look. So when we set up our tabs, we did not remove the view container. This is neither a screen, group, or React fragment. So let's remove that. I'll remove the view. Then in order to keep things tidy, I'll remove the view from the React Native imports. I can also remove the styles that were used for this. There are no other styles set now, so let's also remove the style sheet declaration, and then also the import for style sheet. Let's save this and run the app in the simulator again. This time the app loads, and I can see the 3 tabs set up. When I click through the tabs, I'm able to navigate to the different screens on our app. It doesn't look very pretty though, so we'll go ahead and start looking at how to make this look a bit better. So there's lots of configuration options available to us with React Navigation. As we can see here in the documentation, we can set a tab bar icon. If we look a bit more deeply into the documentation, you can see there's a wealth of other things available too. So we can set labels and positions and so on. In our app, we already have the names showing on the tabs for the different screens, but we're going to customize things a bit further. We're going to set an active and an inactive color for the tab bar. Then we're also going to set icons for each of the tab bar items. As we can see in the documentation, we set the active and inactive tint colors on the navigator, and then we set the icons in the tab. So back in our code, in the tab navigator, we're going to say screen options. Then we'll use an equal sign and some curly braces. Inside the curly braces, we use another set of curly braces. And then we say tab bar active, tint color. We're going to set this to the string tomato. Next, we'll say tab bar inactive tint color. And we'll set this to be grey. For the tab icons, we're going to use some icons again from Feather and Expo icons. So we'll start by importing this at the top of our file. We say import, then we use some curly braces, and inside the curly braces, we say Feather. Then we say from @expo / vector icons. So to set the tab bar icon, we can use the tab bar icon property. As it says in the documentation, we can use it on our screen components in the options prop, although for their example, they've placed it in the screen options prop of the tab navigator. In our implementation, we'll be using it in the screen components options. So in the first screen, I say options. Then I use an equal sign, and then I use 2 curly braces. Next, I say tab bar icon. And for the parameter, I'm going to pass in focused. This is because we're going to want to set a different colour for the icon depending on whether the tab bar icon is or is not selected. Next, I use an arrow and then some parentheses. Inside the parentheses, I'll render the feather icon. So I just say feather. I've already selected the icons for the tabs here, so I'll say name equals, and inside curly braces, I'll set this to be droplet. I'll set size to 25, and inside colour, if the icon is focused, we want to return tomato. Otherwise, we want to return black. Now we need to repeat these steps again for our other 2 screens. So in the screen with the upcoming weather, I say options, then an equal sign, and 2 curly braces. Next, I say tab bar icon. And for the parameter, I pass in focused. Then I use an arrow and some parentheses. Next, I set up the feather icon. This time for name, I'll set it to be clock. I'll set size to 25, and for the colour, I'll say if focused, then show tomato. Otherwise, show black. Then for the city screen, we do this again. So I say options, and I use the two curly braces. Inside of the curly braces, I then set the feather icon up. I set name to home, size to 25, and for the colour, I say if it's focused, use tomato. Otherwise, use black. So now the tab icons and styling should be set up. Let's save everything and see where things are at in the simulator. So back in the simulator, we see all of our tabs set up with the tabs and the icons. Everything should now be running correctly. In order to make our code a bit easier to follow, I'm going to extract the tabs into their own component, and then I'll import this into the app.js file. So inside the components directory, we'll create a file called tabs.js. Next, back in the app.js component, I'm going to copy all the imports and the initialization of the tabs. Then I'll paste this into the tabs file. Now I can go ahead and create the component. So I say const tabs equals, then a set of parentheses, an arrow, and some curly braces. Inside the curly braces, I'll say return, and I'll use some parentheses. Outside of the component, I'll say export default tabs. Now I'll go back to the app.js file and I'll copy everything related to the tabs. Next, I'll paste this into the tabs.js file. Back in the app.js file, we can now delete all the code related to the tabs. Now, if I go back to the tabs component, I need to update all the imports for my screens, as we're now inside of a directory and not at the root of the project. Back in the app.js file, I can then delete all the imports which are now not needed. Lastly, in the render, I can just pass in the tabs component. So now everything's much more readable. Let's save this and view it in the simulator. Everything looks good, and we see the tabs in the simulator still. When I click on a tab, it changes colour, and our tab code is extracted into its own component, so everything is nice and tidy. If we go back to the code for the tabs component, you may see an ESLint warning. I'm going to just disable this warning for this file, as we need to follow the React navigation requirements and set up our tabs in this way. So before we move on, let's add a few more customization details to our navigation. In the header bar, I get the same name as I do for the tab name, so we don't need to change this, but I'm going to set the background colour of the tab bar and also the background colour of the header bar. After that, I'll go ahead and add some more styles to the font used in the header bar. So in my screen options for the tab navigator, I'll say tab bar style, and then I'll use an object. Inside of this, I'll say background colour, and I'll set this to light blue. This is all one word and all lowercase. Next, I'll set another property called header style, and I'll also use an object here. I'll set the background colour also to light blue. Then I'll set a property called header title style, and I'll also use an object for this. Inside of this object, I'll say font weight of bold, font size of 25, and colour to be tomato. Let's save this and check things out in the simulator. So now we can see our tab bar and header bar. Both have a matching background colour. The font in the header bar is a bit larger and bolder, and the colour of the selected tab matches the colour of the header bar title. There's a ton of customization options available to you with React Navigation, so I strongly advise you spend some time getting familiar with the documentation. You can see a bit more about the header bars here. So we're shortly going to move on and look at state and then data fetching in our app. After that, we'll look at using the real data in our components. In order to prepare ourselves for this, though, there's one more file I would like to implement. In our current weather component, we currently have an icon and a message description set for when the weather is sunny. In the completed app, we're going to show a different icon and a different message based on the weather. Additionally, we're going to change the background colour of the screen to represent the different weather. We'll base these different states on the weather conditions provided by the OpenWeatherMap API. So we're going to create a file which contains these conditions, and then the icons, message, and background colour, which should be shown for these conditions. So we'll start by creating a directory to store this, which will be called utilities. So let's do that now. In the src directory, we'll create a new directory called utilities. Then we'll call the file, which will store these properties and values, weather type. Inside the file, we need to create an object. So we say export const weather type. And then we set that equal to an object. Because of the data provided by the API, we need to capitalize the weather types. We'll start by creating the objects for each of the weather types. The first one is called thunderstorm. The next is drizzle. Then we set rain. Next we'll set snow. Then clear. Clouds. Haze. And mist. So let's start by setting up the thunderstorm type. We'll set an icon and give this the value of the string zap. Next, we'll set a message and we'll set this to the string it could get noisy. And then we'll set a background colour to the black hex colour value of 000 000. Note that this is passed in as a string. So the next one is drizzle. This one will have an icon of cloud dash rain. Then for the message, we'll say it might rain a little. Then we set the background colour to 364 54 F. For rain, we'll set the icon to umbrella. And then for the message, we'll say you will need an umbrella. And the background colour will be 000 0FF. For snow, we'll set the icon to cloud dash snow. For the message, we'll say let's build a snowman. And the background colour will be set to 7F6 065. Next, for clear, we'll set the icon to sun and we'll set the message to it is perfect t-shirt weather. And the background colour will be set to E47 200. Now for clouds, we'll set the icon to cloud. We'll set the message to you could live in the clouds. And then the background colour will be set to 363 636. Now for haze, we'll set the icon to wind and the message will say it might be a bit damp. And then for the background colour, we'll set this to 585 86E. And then lastly for mist, we'll set the icon to align dash justify. The message will be set to it might be hard to see. And then the background colour will be set to 3E3 E37. Right, That was a lot of typing, but now we can try this out, even though we don't have any real data yet being used. If we go back to the current weather component, we can start by importing this file. As we're not importing a component, but we're importing an exported object, we need to use curly braces. So we say import, and then we use curly braces. Inside the curly braces, we say weather type. And then we import this from utilities / weather type. So let's test this out on the weather condition message. So inside the last row text component, inside the message to prop, we can just say weather type and then use square brackets. And let's try out the message for the thunder weather condition. So as we're using square bracket notation here, we pass in the string. Let's save this and see what things look like in the simulator. So now we're going to move on to some of the more deeper topics in React Native, and we're going to take a step back from our app, just for a bit, in order to take the time to learn some of the details required to successfully make our app more dynamic. Dynamic is the key word here. So far in our application, everything has been static. This means that we have all our screens, and all of these are now wired up with navigation. But nothing in our app really does anything, except display values to the user, which we have hard-coded in ourselves. If this is all you wanted to do, then you only need to use props, just like we have, and you can pass your data around from parent to child components. But isn't the real excitement of making applications these days how interactive we can make them, and how fun we can make the experience for the user? When was the last time you enjoyed using an application, either on the web or on mobile, that only functioned in this way? With React Native and React, we're able to make the user experience super interactive and update and respond to users' input. So given this intention, props are only half of the story. The other half is state. State is what I'm going to introduce you to now. So what is state? To put it simply, state is an object, and this object contains data about the component that for some reason we decide we need to keep track of within our application. In the object, we define key value pairs, and these key value pairs are the way in which we track a single piece of data that over time is going to change. Let's visualize this a bit more. If we go back to the house example from when we looked at props, using the props, we pass data down to each of the rooms in the house. Using state, though, we can be inside a room and keep track of something that is going to change in the room. So perhaps we want to keep track of the messy state. Or maybe we want to keep track of whether the room was dark, so we could track the value dark as true or false. Or maybe we know a massive storm is incoming, so we want to keep track of whether or not the room is wet. The benefit of state within a React Native or React application is that it means things can change. They can be added, modified, and removed. And we, as the developer, can work with this more easily and update our internal data and trigger UI updates based on these changes. There is one very key point to be aware of here, though. When the data in our component changes, the component will re-render. So to emphasize this point, when a component first renders on the screen to the user, we have what is called an initial render. If we're using state, and some of this state changes, then the component will re-render itself. So let's look at this through our room example when the storm is possibly incoming. Our room component renders on the screen when it first loads. We have a wet state, and this is set to false. Later, the storm happens. Our room gets flooded. This causes the wet state to get set to true. Consequently, the room component then re-renders. In the world of coding, this sort of change might be more likely to occur based on a user event, such as a button press, or perhaps some sort of user input, such as typing something into an input field. It's totally fine if this all seems a bit overwhelming or confusing right now. It can be a lot of information to process. Let's stop for a moment and summarize what we have just learned. We have learnt that state is an object that is used to keep track of data about a component. We've learnt that by using state, we can add, remove, or modify things in our component more easily. And then we can trigger UI updates based on these changes. Additionally, we've also learned that when state changes, it causes the component to re-render. So let's just be very clear now on the difference between props and state. Props let us pass data between the components, whereas state lets us internally manage the data within a component. You therefore can't modify the state of a component outside of the component. In this sense, it's a bit like when you're working with local scope in JavaScript. Of course, with vanilla JavaScript, you can make things dynamic, but the benefit of working with React Native and React is that a lot of the hard work is done for you, and you just have to provide initial values and then consider how you would like this value to update, and then also be displayed to the user. If and when your state grows, you need this to be at an application level, then you can also access libraries to help you manage this, such as Redux. But that is out of the scope of this course. So we're going to continue our journey with state by creating a simple counter component, which won't be in our final app, but will hopefully solidify our understanding a bit more here. We'll start by creating the component without using state, so hopefully we can better see why we need state, and then we'll add state to the component. So inside the src directory, I'm going to create a new directory called demonstration. You're welcome to keep the code in this directory for reference purposes, or delete it from the final project at the end of the course. But it saves us from having to create a new app for any demonstration code which we'll make during the rest of the course. So in the src folder, let's create this new folder called demonstration. Now, inside of this folder, I'm going to create a component called counter.js. We'll set this up just like we have with our other components. So we'll start by importing React from React. Next, we'll import Vue, Text, Button, and Style Sheet. And we'll import these from React Native. Now let's go ahead and create the component. Hopefully you're getting used to doing this now, but we'll start by saying const counter, and we'll follow this by an equal sign, some parentheses, an arrow, and some curly braces. Outside of the curly braces, we'll export the component. So we say export default counter. Inside of the curly braces, we'll say return. And we'll use a set of parentheses. Then before the export, we'll create our style sheet. So we say const styles equals style sheet dot create. And then we use some parentheses and some curly braces. So let's set up our component. Before the return, I'm going to create a variable which will store the value of count. So I say let count, and I set this equal to 0. Now inside of the return, we can create a view. Then we'll also create some text. Inside of the text, we're going to use a template literal and interpolate in the count value. So we use curly braces and then some backticks. We say count and a colon. Then we pass in the count variable. Next, we'll add 2 buttons. For the first button, we'll set colour to red. For the title, we'll say increase the count. And then we set on press. For this, we use an arrow function. So we use some parentheses and an arrow. For the first one, I'm actually going to use curly braces because there's a little bit more I want to do here. So firstly, I'll increment the count. So I say count plus plus. And then I also want to add a console log to print out the value of the count variable. For the second button, we'll set the colour to green. For the title, we'll say decrease the count. And for on press, I'll just pass in an arrow function, which will decrement the count. Let's add a couple of styles. On the view, we'll set a container. So I say style equals styles dot container. And for the text, I'll set some styles called title. So I say styles equals styles dot title. In the style sheet, I'll set the container. I'll give this flex of 1 and background colour of orange. Next, I'll set the title. I'll give this align south of centre and font size of 25. And then I'm going to set a margin top of 25. We also need to be able to see this component on the screen of our app. So let's go back to our app.js file. I'm going to start by importing the counter. And I'll do this from /src/demonstration/counter. Temporarily, I'm going to remove the tabs from the render in the component and replace this with the counter. Now let's load the simulator. We now see our counter component on the screen. We see the 2 buttons and also the text which displays the counter value. Great. So let's now click the button to increment the counter. So it looks like the button was pressed successfully, but the count value has not updated on the screen. Let's dig into this a bit more and we'll check the console log we added. So it looks like this did increment. I'll press the increase button again. We now see 2. So the counter value is definitely increasing, but the text that displays the count on the screen is not showing the correct count. So the reason for this is that React does not re-render a component when the value of a variable changes. If this happened, we would end up with re-renders happening all over the place, and it would result in a really bad user experience. I mentioned when we looked at state that when we use state and the state changes, the component re-renders. So this is a great example of a use case for state. We'll look more deeply at hooks in a bit, but we're going to use a hook provided by React called useState in order to fix our problems here. For now, you can think of a hook as functions that we can use inside of our function components. All of the components we have made throughout this course have been function components. So to start off, we need to import the useState hook. We do this when we import React. So in the React import, we add a comma, and then some curly braces. Inside of the curly braces, we say useState. Now, when any values we use with the useState hook are updated, then React will ensure the component also gets updated to reflect these changes to the user. So now we need to update the declaration for our count variable and use the useState hook instead. So let's delete the variable and we'll start again. This time we use the hook. So we say const, and then we use square brackets. And we say equals useState. Inside the square brackets, I'll say count, and then set count. Lastly, inside the parentheses for the useState, I'll set the value 0. So when we use the useState hook, we're setting up some piece of state for our component. When useState is set up, we need to pass in the initial value for what the state should be. So if we were implementing the flooded room example here, we might have to set this up by saying is flooded, and set is flooded. And then in the parentheses, we would have said false for the initial value. We want the counter to start at 0, which is why here we're passing in 0. We can pass in any of the data types required for our needs though, so this could also be a string or an object and so on. The square brackets where we have added count and set count are simply using array destructuring. The first value in this is the count, and this tracks the value for the count. But we never directly change the value of count. Instead, we use setCount, which is a function, and into this we pass what we want the new value for count to be. So let's go ahead and update our component to use this. In the first button, I'm going to remove the console log, and also the incrementing of the old count variable. Then I will say setCount, and I will pass in count plus 1. So we aren't modifying count here, we're just getting the value of count and then adding 1 to it. In the second button, I'll say setCount, and this time I'll pass in the value of count again, and then -1. Let's save this and go back to the simulator. Now let's press the increase button. The count displayed on the screen updates to show our new count. Now let's press the button to decrement the value. The value on the screen now decrements. So now we have successfully worked with state for the first time. Let's recap what we have just learned. When we want to use useState in a function component, we can use a hook called useState. We never directly change the value for the state, but we can update it via a function that enables us to update the state. We use array destructuring for the useState hook, and inside this we have the value for the state, and then the function we use to update the state. And inside this we have the value for the state, and then also a function that we can use to update the state. Inside the parentheses of useState, we also set the initial or default value for the state. Before we move on, in the last section I introduced you to hooks, and I want to go over these in a bit more detail, and then I'm going to move on to showing you another hook which will help us with our data fetching. Back in the older days of using React and React Native, in the most part, we had two types of components that we could use. These were called stateful and stateless. If we wanted our component to use state in some way, we would create a stateful component. If we did not need to use state in our component, then we could use a stateless component. A stateful component was a class, and the syntax for a class component looks like this. We can still create class components in React today, so they're worth knowing about, and you may very well come across some older code that uses them. When you use class components, you can access what are called lifecycle methods. Lifecycle methods are essentially events that occur during the lifecycle of a component. It's a little bit like key events that occur during the life of a human. A human gets born, they have an annual birthday, and later in their life they pass away. When a component is created, it is mounted, and the lifecycle method for this event is called component_did_mount. When the component updates, another lifecycle method is called, which is named shouldComponentUpdate, and this lets you control when the component should re-render. Just before the component is destroyed, another lifecycle method is invoked, called component_will_unmount. When you're using a class, you can tap into these methods, and during these events, you can add some additional functionality. If you want to read more about lifecycle methods, you can find some details here. As React has evolved, there's been a tendency to move away from using class components, and these days function components are favoured. When components were either stateful or stateless, this wasn't very practical. But in React 16.8, hooks were introduced. Hooks provide us with a way to use the features we depended on classes for, like state and lifecycle methods, but from inside of our function components. You can think of hooks like special functions, or pieces of reusable logic which are separate from our component tree, but that let us add functionality to our function components. When we use hooks, we can isolate all the logic from the component in a readable way, but we can use them within our component. You can read more about hooks here. Every hook in React starts with the word use, and we've just seen an example of this when we looked at the useState hook. There are a couple of rules you should be aware of when you're using hooks though. Firstly, you can only call hooks from React functions, like our functional components. You can't just use them wherever inside normal JavaScript functions. Additionally, hooks must be called at the top level of a component and before the return keyword is used. We'll see more about this later, but aside from React hooks, you can also create your own hooks, and these hooks can call other hooks. We're going to move on now to introducing ourselves to another hook from React, called useEffect. After this, we'll return back to our app and start looking at data fetching. The useEffect hook is extremely powerful, but it can also seem quite overwhelming when you're first looking at it. If you can understand how to use the useEffect hook properly, then you can do all sorts of things with your application. Let's start by looking at the documentation. So it says the effect hook lets you perform side effects in function components. The example also goes on to state that it's similar to component_did_mount and component_did_update. Let's break this down a bit. To start with, what is a side effect? Well, it's when we use something not inside of React within our component. So examples of these sorts of things are fetching data, using timer functions, and updating the DOM directly. We also know that component_did_mount happens when the component is first mounted, and component_did_update is called after updating occurs. So useEffect essentially lets us replicate these lifecycle methods, and it means we can perform side effects, like fetching data, from within our function components. So let's go ahead and look at the basic syntax for the useEffect hook. If we look carefully, we can see that useEffect takes in a function as an argument, and it's inside of this that we can write our side effects. Let's add the useEffect hook to our counter example so we can understand things a bit more deeply. So inside the counter component, next to the useState import, we need to start by also importing useEffect. Next, under the useState hook, we can use useEffect. So we say useEffect, and then we pass in a function. Now inside the function, let's add a console log for the count. So I say console log, and then inside this I'm going to use backticks. And then I'll say our count value is, and then I will interpolate in the value of count. Now let's see this in action in our simulator. I'll start by reloading the screen. So now, in the console log, I see the initial value of count printed to the screen. Every time I click one of the buttons, as the component is re-rendering here, I see the new value of count printed to the screen too. So we could be doing anything in here that we want to happen as soon as the component first renders, such as fetching some data. Right now, we're also repeating the code inside of here every time that the component re-renders. If we take a look at the React docs again, we can see that useEffect also takes one other parameter called dependencies, which it compares to the lifecycle method component did update. It says on the documentation that you can tell it to skip applying an effect if certain values have not changed between renders. To do so, you pass an array as an optional second argument to useEffect. So to summarize this a bit, inside of this array, we pass in all of the values that the side effect inside of useEffect relies on. In our example, we're console logging based on the value of the count. So we need to include count inside of the dependencies array. This now means that the code inside of useEffect will only run if that value has changed between renders. If we do not pass in the dependencies array, then the code inside of useEffect will run after every render. Let's look at this in our demonstration. I'm actually going to add 2 new buttons to the component. I'll just copy and then paste the first 2 buttons. Next, I'll create another count and set count with a new useState hook. I'll call the state variable here newCount. And then for the function to update the state, I'll call it setNewCount. And then I'll update the onPress inside of the new buttons to call setNewCount. So now, inside of the useEffect, I'm going to change the console log to just be count changed. Let's run this in the simulator. When the screen loads, I get count changed printed to the console. Every time I press any of the buttons, I see the count changed console log printed to the screen again. So now let's go back to our code, and we're going to pass in a dependency array. Inside of the dependency array, I'm going to pass in count. Now let's run this again in the simulator. So I get the console log printed to the console when the screen launches. This time though, I only see this printed to the screen again when I click on any of the first 2 buttons, which use count. I don't, however, see it printed to the screen when I press any of the buttons that use newCount. So the effect only runs when count changes, otherwise it just sits there and it doesn't do anything again. The last thing you need to be aware of when you are using useEffect relates to the component will unmount lifecycle method, and it's called the cleanup function. This cleanup function allows us to turn off or clean up our side effects. So for example, if you're using a counter, we would need to use the clear interval function to stop the counter, and this is where we would place that, and by doing so, we can avoid memory leaks. To use a cleanup function, we type return, and then we use an arrow function, followed by the cleanup we would like to perform. We can see an example of this on the React documentation again. As the documentation says, React performs the cleanup when the component unmounts. So we don't really have any cleanup we need to do in our example, but I'm going to add a console log here to show how this works. So back inside of our code, and inside of the use effect, I will say return, and then I'll use some parentheses, an arrow, and some curly braces. Then I'll just console log a string which says use effect cleanup. Let's save this and go back to the simulator. Now when I click one of the buttons, which triggers a re-render, I also get the console log for the cleanup logged to the screen, because the cleanup is called before the next use effect runs. So before we move back to our app, let's do a bit of recapping about everything we've just learned with use effect. We have learned that use effect is a hook provided by React, which lets us run code that has side effects. We've seen that it takes a function with the code to run. Then we saw that you can also pass in a dependency array, which lets you specify what data, when changed, that you would like to trigger a re-render. Lastly, we looked at the cleanup function that we can use with use effect to run any cleanup and stop any of the side effects before use effect is called upon a new render and when the component is unmounted. So now we have some understanding around hooks and use state and use effect. So we're ready to go back to our app and think about our next steps with our weather application. So, back in our app, we have a few things that we're going to do now in order to make the app dynamic. To start off, inside the app.js file, I'm going to reset the code to use the tabs inside the render. And I'm also going to delete the import for the counter. I'm going to break down the next steps we need to achieve. The first thing we're going to do is implement a loading state for when the app first launches and the data is being fetched. This is so the user sees something during this process. It's always good when you're making applications to consider all the various loading and error states that the user might encounter. After this, we're going to look at fetching the data from the OpenWeatherMap API, and this will be broken down into two parts: getting the user's location and then fetching the data. So let's start first with the loading state. As I mentioned, we want to start the app in the loading state until the data from the OpenWeatherMap API is successfully fetched. Once it is fetched, we'll set the loading state to false and navigate the user onto our weather-related components. For our loading state, we want to display to the user a spinner. Instead of having to manually create this, React Native has a core component that does this for us. It's called Activity Indicator. Let's have a look at the documentation. So we can see the Activity Indicator displays a circular loading indicator to the user, and we can customize the size and the color of the spinner. On the documentation, we can see a few of the activity indicators in action, with the different sizes and colors set. So let's go back to our app, and we'll start to set this up. So inside the app.js file, we'll start by importing the activity indicator. After the React import, I'll say import, then I'll use some curly braces, and inside the curly braces, I'll say activity indicator. And I'll import this from React Native. Next, in order to set the loading state, we're going to use useState. So in the React import, I add a comma, some curly braces, and then inside the curly braces, I say useState. Now this is imported, we need to set up useState. So before the return, inside of the app component, I say const. I use some square brackets, and then I say use state with some parentheses. I'm going to call this piece of state loading. So inside the square brackets, I'll add loading. I'm going to call the function to update the state set loading. So I'll add this too. Then I'm going to set the initial state for our loading state as true. This means when the app first launches, the user will see the activity indicator. Then once the data is fetched, we can set this to false, and then they'll see the weather components. So now in the render, we need to have a way to say, if the state is loading, then show the activity indicator. Otherwise, show the tabs. There are a few ways we can implement conditional rendering in React and React Native. Knowing about if-else statements, ternary operators, and also the logical AND operator is useful when it comes to handling these scenarios, and you can read more about these here. In our case, for now, we're going to keep this very straightforward and just use an if statement, which renders the activity indicator when the loading state is true. If the loading state is not true, then the navigation container and the tabs will be rendered. So inside of our app component, I'm going to say if loading. Then inside the parentheses here, I'll say return. And inside the return, I'm going to add a view. And then also the activity indicator. So we're wrapping the activity indicator inside of a view here so we can better control the layout for it. For our activity indicator, we're going to say size equals, and then we'll set this to the string large. And we're also going to set the color, so we say color equals, and then we set this to the string blue. We also want to set a couple of styles for the view, just so we're sure we're setting the layout for the activity indicator to be in the center of the screen. So in the view, I say style equals styles dot container. Now in the React Native imports, we need to add the view and the style sheet. Before the component is exported, let's set up the style sheet. So I say const styles equals style sheet dot create. And then I pass in the object. I'm going to set the container. And for this, I'm going to say justify content of center and flex of 1. Let's save this and see how it looks in the simulator. When the simulator runs, I see the loading spinner in the center of the screen. If the loading state was set to false, I would see the tabs and our weather screens. So next, we're finally ready to look at getting data from the API. So in order to get data from the OpenWeatherMap API, we need to start by calling the API. Let's take a look back at the API documentation on the OpenWeatherMap website. For our app, we want to display the current weather, but also the upcoming weather. So we're going to use the 5-day, 3-hour forecast. If I click on the API documentation here, it shows us how to make the API call. As we can see, there are a few things that are required to make this successfully. We will need the latitude and the longitude, which are geographical coordinates for where we want to display the data from. And then we're also going to need our API key. Let's start by figuring out how we will get the latitude and the longitude. The technical term for finding geographic data, such as coordinates, is geolocation. If I search for React Native geolocation, we can see that this has been deprecated, and we should use one of the community packages instead. If I click on the link, we can see that there are a variety of packages available. So this is useful if you did not create the app with Expo, and it's also something to know about in the future. But as we created the app with Expo, we're able to use a package called Expo Location. Let's take a look at the documentation for this. So as it says, Expo Location allows reading geolocation information from the device. This sounds exactly what we're looking for. Let's start by installing it. So in our terminal, we need to say npx expo install expo dash location. Now, if we go back to the documentation, we can see all the extra configuration. And then there's also steps provided if you're installing the project in a bare React Native project. In the example provided, we see that we have to complete 2 steps in order to get the user's location. Firstly, we have to ask for permission to access their location. And then we need to get their location. Once we have their location, we need to store this. We also need to be mindful of handling any errors in case we were not able to access the user's location. So for implementing this successfully, we're going to need to use useState in order to store the location and any errors. And then we're also going to need useEffect. So back in our code, let's start by importing useEffect. Next, we will set up 2 pieces of state. We'll do the location first. So we say const, then we use square brackets, and we say equals useState. Inside the square brackets, we'll say location. And then set location. We're going to initialize this with null. Now for the error, we need to set up another piece of state. So we say const, then we use square brackets, and we set this equal to useState. This time in the square brackets, we'll say error and set error, and then we'll initialize this with null. Next, let's set up the useEffect. So before the return, we say useEffect, and then into this we need to pass a function. We're going to pass in a function which needs to be immediately invoked. So inside of the curly braces, we use a set of parentheses. Next, we say async. This is so that JavaScript knows we're using an asynchronous function here. Then we can set this up as a function. So we use parentheses, an arrow, and some curly braces. Inside the curly braces, we say let, then use curly braces, and we set this equal to await, location, dot, request, foreground, permissions, async. Make sure you capitalize the location here. We want to access the status, so inside the curly brackets, we're going to place status. Next, we handle the error using an if statement. So we say if status does not strictly equal granted, then we use our setErrorState function. And we set this to the string permission to access location was denied. And then we say return. Now outside of the if statement, we can continue with the rest of the code for if the request for permissions was successful. So we create a variable using let called location. We assign to this await, location, dot, get current position, async. Into this we pass in an empty object. Lastly, all we need to do is update the location. So we say set location. And into this we pass in the location. Then, as we want to immediately invoke this at the end of the function, we use a set of parentheses. Inside of the use effect, we'll pass in an empty array for the dependencies. This means there's no dependencies and that use effect will only run once when the component is first rendered. In our component, we're just going to add a console log for now, and we'll say if location, then console log location. Before we test this, we need to ensure location is enabled on the simulator or emulator. You can see more information about how to do this in the documentation here. Let's go ahead and test this out in the simulator. When the simulator runs, we see the permission request which we set up. When I click on Allow while using the app, and then launch the console, I then get to see the location data, which includes the latitude and longitude, which we were looking for. It's worth knowing here, as a side note, that when you're using a simulator, the location defaults to San Francisco as opposed to your real location. So now we have this, let's look at getting data from the API. At this point, it would be helpful if you're signed in on the OpenWeatherMap API website. To start with, I'm going to navigate back to the 5-day, 3-hour forecast, and then I'll open the documentation here. Next, I'm going to copy and paste the URL for the API call that we're going to need, as we're going to need that shortly. For now, I'll just paste this at the top of the app.js file. So we need to think about how in the app we're going to store the API key. It's always best practice and safer not to expose any secrets in your application and import them from an external place. This is even more important if you're using source control like GitHub, because you don't want these keys to be visible to anyone. There are a few ways you can go about doing this, and there's some deeper documentation on the Expo site here if you would like to find out more about this. For our example, we're going to use a package called reactnative.env. This means we can use an environmental variable where the value is set from outside of the application. So let's go ahead and set this up. So we need to start by installing it. Back in our terminal, we'll say npm install -d react native.env. Once this is installed, we need to go to our Babel config file and then add the plugin. So after presets, we need to add a comma. And then for the key, we say plugins. And then we use an array. Inside of this, as a string, we say module, React, native, .env. So now we can create the .env file. So at the root of the project, I'm going to create a file called .env. Once this is done, we can test this out. I'm just going to use a dummy value for now, using capitals, which is the best convention. So first I'll set the name of the key to be test _ key. Then I'll say equals, and for this I'll just say 1, 2, 3. Now if I go back to the app.js file, I can import this. So in my imports, I say import, then I use curly braces, and I say from @env. Inside the curly braces, I place the name of my key, which was test_key. So now I'll just add a console log with this. Let's save this and run the app in the simulator. When the simulator runs, if I check the console, I can see the value of the key printed successfully. So we've proven the package was successfully set up. Let's go back to our app. As I'm using Git, I want to make sure the .env file is not pushed. So inside the git ignore, I will add the file name. This means it will not be part of any committing and pushing to Git that I do. So next, let's go back to the .env file. We'll delete the test key, and we'll add our key for the OpenWeatherMap API. I'll call this key weather underscore API underscore key. The next thing we're going to need to do is to get the API key. So back on the OpenWeatherMap website, as long as you're signed in, you can click on your user and then My API Keys. On this screen, you can copy and paste the key if you have one. Otherwise, you can generate one by selecting Generate and then copy and paste it. If you now go back to your .env file, you can paste it in. And then we should be good to go. So the last bit of setup we need to do here, if we go back to the app.js file, we can change the import for the test key to be weather API key. Now we can look at how we're going to fetch the data. So to fetch the data, we're going to use the Fetch API, which is what React Native provides us with to work with networking. If you haven't used this before, you can read more about it here, and also here. So back in our app.js file, we're going to start by creating a new piece of state to store the weather data. Hopefully you're becoming more familiar with this now, but we'll say const. Then we'll use a set of square brackets, and we'll set this equal to useState. We'll call this weather. So let's add that into the square brackets. Then we'll call the function to update the state, setWeather. We'll initialize this as an empty array. So next, we're going to encapsulate this data fetching inside of a new function, which we'll call fetchWeatherData. So before the use effect, we'll say const fetchWeatherData. And we'll use an equal sign. And then async. Next, we'll use some parentheses, an arrow, and some curly braces. So now inside the curly braces, we can then set the response. So to start, we declare a variable using const called res. And to this, we'll say await, fetch, and some parentheses. Inside the parentheses, we can paste in the URL we want to fetch the data from. So we're going to use backticks here, as we're going to need to interpolate in our environment variable. So we'll say http:// and 2 forward slashes. Next, we can paste in the URL that we commented out earlier. We'll update these values shortly. So next, we need to create another variable to get the JSON data. So we'll say const data, and we'll assign to this await response dot JSON. Once we have this, we can call our setWeatherState function. So we say setWeather and into this we pass data. Also, once this is done, we can set the loading state to be false. So we say set loading and pass in false. Then inside of the use effect, after the location is set, we can say await fetch weather data. So let's now format the URL that we passed into fetch. So inside curly braces, we have the latitude and longitude and also the API key. So to start with, we need to get the latitude from our location piece of state. So we say location dot coords dot latitude. And then we can do the same for the longitude. So we say location dot coords dot longitude. Now where the API key is, we can pass in our weather API key. We also need to make sure we're using interpolation here, so we need to add dollar symbols before each of the curly braces. There's also some error handling we need to do here, so if the response fails in some way, we can set our error state. To achieve this, I'm going to wrap everything inside of a try-catch statement. So I say try, then I use some curly braces, and then I say catch, and I place error inside of the parentheses. Then I use another set of curly braces. So inside the try, I will place everything we've written. And then inside of the catch, I'll say set error. And then inside parentheses, I'll use a string. And for this, I'll say could not fetch weather. Additionally, I'm going to use finally here. This is used to execute something after the try catch has been completed. So I'll say finally, and I'll use another set of curly braces here. I'm going to move set loading from the try statement into here. The reason I'm doing this is so that we have either the data or the error. Once either of these is set, we can set loading to false, and then we can navigate to the correct screen for this state. Of course, this also means we're going to need to add a screen to show the user if there is an error, but we'll add that a bit later. So there's one last bit of refactoring I want to do now. When we initially set up the location, we set one piece of location and then pulled out the required values in the API call. I'm going to update this so we have two separate pieces of state, one for the latitude and one for the longitude. So I'll start by creating these. I say const, and then I use some square brackets, and then I say equals, use state. Inside this, I'll place an array. I'll call the state lat, and then the function to update the state, setLat. Next, I'll do the same for longitude. So I say const, then I use square brackets. I initialize this with an empty array. I'll call the state lon, and the function to update the state, setLon. Next, inside the use effect, instead of saying set location, I'll say set lat, and then location dot coords dot latitude. Then I'll do this again for the longitude. So I'll say set lon, and then I'll pass in location dot coords dot longitude. Then I can update the API call instead to use the lat and lon pieces of state. Additionally, I'm going to pass these in as dependencies inside of the useEffect array. This means when these change, the useEffect will rerun. Let's also remove our initial location piece of state. So now let's add a console log to see if we can view the weather data. So we'll say if weather console log weather. Let's save this and see how things are in the simulator. So now when we look in the console, we can see the weather data has now been set up and is visible to us. So now we have all the data we need coming down from the API. Next, I'm going to do a bit of refactoring because our app component has quite a lot of logic inside of it at this point. So I'm going to extract the current hook usage into an external file. You can make custom hooks and then import them, just like when you use a React hook. The benefit of this is that we can better encapsulate the logic. In our case, we're going to end up with quite a few things going on, so doing this means our code is much easier to work with. The only requirement when we do this is that we name it with something that starts with use, just like when we use hooks which are from React. So to start, I'm going to create a new directory called hooks. Now inside here, I'm going to create a file called useGetWeather.js. I'll go to this file and I'll start by creating the function. So I'll say export const useGetWeather. As this is a function, I need to use an equal sign, some parentheses, an arrow, and some curly braces. Let's think about what we need to add in here. We want all the data fetching logic from the app.js file, so let's start by getting that, and then we'll paste it inside of the function. We're also going to need to get all of our state, because this is depended upon by the functionality inside of the hook. So back in the app.js file, I'll copy all the state setup. Then I'll go back to the custom hook file, and I'll paste this at the top of the useGetWeather function. Lastly, we're also going to need some of the imports. So let's grab everything from the app.js file, and then we'll paste it at the top of the hook file. So we can delete the React Native and the navigation imports here because they're not used. Lastly, at the end of the hook, we need to return, inside of an array, the pieces of state that will be needed by our app component. So for us, this is the loading state, the error state, and the weather data. The app component itself does not need the latitude and longitude, so we can keep these scoped only inside of this hook. So at the end of the hook, after the useEffect, we say return. And then we use an array, and we'll pass in loading, error, and weather. At this point, we could actually now use this hook inside any component we wanted. So this is really helpful if you have some reusable code which is required by multiple components, as it means you don't need to duplicate logic. Now we're ready to use the hook in our app component. So if we navigate back to the file, we can start by importing the hook. I'm also going to delete all the unused code now. So now we can use this, and we simply just destructure the values. So at the top of the app file, we say const, then we use square brackets, and we set this equal to useGetWeather. The values to place inside of the array are loading, error, and weather. So now we can add a console log with loading, error, and weather. Let's save this and test this out in the simulator. When the simulator runs, I now get to see the loading, error, and weather data printed out in the console. So we have proven this works, and we now have all our logic scoped inside of its own hook. So the next thing we're going to do now is look at wiring up each of our weather components with the real data. So to start with, we need to pass the weather data to the tabs, and then we'll need to decide which pieces of data are required by which component. So back in our app.js file, let's set a prop on the tabs called weather. And we'll set this to weather. I'm also going to change the render order here. So if the weather exists, we render the tabs. Otherwise, we'll show the activity indicator. So I'll place the rendering for the tabs to be above the rendering for the activity indicator. And then I'm going to enclose this inside of an if statement that says if weather and weather.list, then return the navigation container. Then I'll remove the condition around the activity indicator and just return this. So essentially here we're saying if the weather exists with the data, we'll render the weather, otherwise show the activity indicator. We'll update this a bit more later to show an error screen if the error state is true. So now let's go back to the tabs component. Now inside the tabs component, we can start using this. If we take a look at the data that we get back from the API, we can have a think about what each component will need. The current weather component only needs the current weather, so we can pass it the first element of the list array. For the upcoming weather, we can pass everything from the list array. Then for the city, we can just pass in the city data. So we're going to do this process component by component, and we'll start with the current weather component. In order to pass the props to the component, we need to render a callback to return the element to use for the screen, instead of using the component prop. So let's start by setting this up. We'll remove the component prop, and then we'll set up the tab screen to return a child. Now we can pass in the component, so we use curly braces, a set of parentheses, an arrow, and then the current weather component. On the component, we'll pass the props. So we say weather data, and we set this to weather dot list. And then using square brackets, we'll access the element at the position of 0. So next we can go to the current weather component, and we'll add the weather data prop. Let's add a console log for this and check everything is wired up correctly here. So I'll run the app in the simulator. Now I'll check the console. Brilliant. I now see the data in the console, and we're good to go with wiring up this component to use this data now. So let's open our current weather component. Now we can have a think about what we need to do in order to get this up and running properly. The pieces of data I'm going to need for this component are the temp, feels like, temp max, temp min, and weather. So to start with, I'm going to destructure these from the props. So I start by saying const, and then I use a set of curly braces. Everything except the weather itself I need to get from main. So I say main, I say temp, feels like, temp max, and temp min. Outside of the curly braces, I use a comma, and I say weather. Then I set this equal to weather data. Next, in order to access the correct weather type object, I'm going to need access to the weather condition. So I'm going to create a variable to store this. I'll say const weather condition, and I'll set this equal to weather, square brackets, 0, dot main. The first thing we're going to do is update the background colour for the screen so that it's set dynamically from the weather type utility file. Because we want to use a property based on the data, we're going to need to do this inline so that we have access to everything we need. So for the style on the safe area view, we'll add in an array. After the wrapper, we'll add a comma. Then we'll use inline styles to set the background colour. So we use an object, and inside this, we'll set background colour. We'll set this to be weather type, and then we need to pass in the weather condition. So we'll use square brackets, and then inside of the square brackets, we'll place weather condition. Outside of the square brackets, we then want to access the value of the background colour. So we say dot background colour. Next, we can do a similar thing to dynamically set the icon. So for the feather element name, we'll add curly braces. And then we'll say weather type. And then we'll use square brackets. Inside the square brackets, we'll say weather condition. And then outside of the square brackets, as we want to access the icon, we'll say dot icon. I'm also going to update the colour to be white. Next, we can update the temperature text to use the temp value. So we need to add curly braces here as we're passing in a value. And then inside the curly braces, we can add temp. For the feels like temp, we also need to use curly braces. Here I'm going to use a template literal, so inside the curly braces, I'll add backticks. Then I'll say feels like, and I'll interpolate in the feels like value. The first row text shows the high and low temperature, so I need to update the message 1 and message 2 values. I'm going to use template literals here again. So for the message 1, I'll use backticks. Then I'll say high, then a colon, and I'll interpolate in temp max. For message 2, I'll again use backticks, and I'll say low, colon, and I'll interpolate in temp min. For the next row text, we want to show the weather description, which comes from the data, and then we also want to show the weather type message. So for message 1, I'll say weather, and as this is an array, I need to use square brackets and pass in 0. Then I say dot description. For the message 2, instead of passing in thunderstorm, I can remove this string and instead just pass in the weather condition. Let's save this and see how things look in the simulator. When the simulator runs, I see the current weather component, but we're now using the values from the weather type, and everything is using the real data. There is one thing though, the units are currently in Kelvin. On the Open Weather Map documentation, we can see this is the default. On our app, we want to use metric, so we need to add this to the API call. If we go back to the useGetWeather hook, we can append this to the API call. We use the and symbol, and then we say units equals metric. Now, if we reload the simulator, we can see the new values. This screen will now look different every time the weather type changes. So that is our current weather component updated for now with the data. Next, we can move on to updating the upcoming weather component. Let's go back to our tabs and set this up. So back in the tabs component, we'll remove the component prop and then set up the tab screen to return a child. Then we can pass in the component. So we use curly braces, and then a set of parentheses, an arrow, and then the upcoming weather component. Next, on the component, I'll say weather data, and I'll pass in weather.list. This means we have access to all the upcoming data. So next, I'll go back to the upcoming weather component, and I'll pass in weather data to the component. I'm going to start by removing all the dummy data we added. Additionally, I'm going to remove the title for the component. So I can also now remove the text from the imports. Next, in the data prop of the flat list, I'll pass in weather data. The values for the list item inside of render item are already set up from the dummy data. So now we can go straight to the list component and see what we need to update. In this component, we also have all the props set up from the dummy data, but we need to do some refinements here. I'm going to start by updating the icon to use the icon from the weather type dynamically. So to start, I need to import the file. So I say import, then I use curly braces, and inside the curly braces, I add weather type. And I'll import this from utilities/weather type. Then for the feather icon name, I'll remove the string sun. And I'll say weather type, square brackets. I'll pass in condition into the square brackets. And then I'll say dot icon. Because space is limited for the list item, I'm then going to change the min and max temperature to be all on one line. And I'm also going to round these values. So to start, I'll delete the text with max. Then I'll use a template literal and interpolate in math dot round. And I'll pass in min. Then I'll interpolate in math dot round, and I'll pass in max. I'll separate these with a slash. Also, we want to show the degree symbol on each of these values. On a Mac, I can do this with Option-Shift-8. On a Windows, this is Alt-0176. Next, we'll look at formatting the date text, and I'm going to use a library to help us with this called moment.js. Moment.js helps us pass and format any data related to time and dates. It's a really useful library to know about because it provides a lot of options for how to display what can sometimes be quite complicated data to the user. Let's start by installing it. In the terminal, I need to type npm install moment -- save. We're going to split the date text into two sections, one that shows the day and one that shows the time. So back in the component, let's add another piece of text under the one that currently shows DT text. Also, to display these, we're going to want these to be split onto two lines. So we'll wrap these inside of a view. And then we'll set some styles here. We'll just call these date text wrapper. Inside the style sheet, let's add this. And then we can set flex direction to column. Now to format the value, we need to start by importing moment. So at the top of the file, we say import moment from moment. So let's have a quick look at the documentation. On the first line, we want to show the day, so we can do this by passing in dd. We then want to show the time on the next line, and we can do this by passing in h, s. Let's go back to our component and set this up. So for the piece of text where we want to show the name inside of the curly braces, we say moment, and then pass in dt.txt. Then we say .format, and we pass in the string dd. In the second piece of text, we say moment, and again pass in dt.txt. Then we say .format, and this time we pass in h, ss, and then followed by a space, followed by a. So the a will show the AM or PM. Let's save all of this and see how this component now looks in the simulator. When the simulator runs, we now see all of our list data showing on the screen with the new layout improvements. So next we need to go back to our tabs component and move on to wiring up our city screen. So back in the tabs component, we'll remove the component prop, and then we'll set up the tab screen to return a child. Next we can pass in the component. So we use curly braces, a set of parentheses, an arrow, and then the component. Now we can pass in the data. So we say weather data, and we pass in weather.city. Now let's go back to our component. Let's start by setting the prop in the parameters. And then we can destructure out the values we're going to need. So I say const. Then I use some curly braces, and I set this equal to weather data. Inside the curly braces, I'll add name, country, population, sunrise, and sunset. The first value we're going to update is the city name. So I can remove London, and I'll add some curly braces. Inside the curly braces, I'll add name. I can now do the same for country. So I remove UK, and then I add some curly braces. Inside the curly braces, I'll add country. Next, I can update the first icon text, body text value. I'm going to use a template literal here, so I'll remove 8000. Then I'll use some backticks. Then I'll say population, colon, and I'll interpolate in population. I can then move on to updating the second icon text. I'm going to use moment again here to help us with our formatting. So I'll import moment from moment at the top of the file. Now back in the body text, I will say moment, and I'll pass in sunrise. Then I'll say dot, format, and pass in h, colon, colon, ss, and then a space, and a. Then for the last icon text, body text value, I'm also going to use moment again. So this time I say moment, and I'll pass in sunset. Then I use a dot, and I say format. Inside format, I pass in h, colon, colon, ss, then a space, and a. Let's save this and see how it looks in the simulator. Everything for the screen looks good, and this has now also been updated to use the data from the API. So that's all our existing screens set up to use the data. There's just a couple of minor fixes I want to do. I want to add the degrees symbol to the current weather component. So let's go back to that component now. In the first two pieces of text, I'll add the degrees symbol here. I also want to add a space between the high and low text. So on the message 1 prop here, I'm just going to add a space at the end. So now we have these refinements done, let's move on to creating an error screen for the application. Inside the components directory, I'm going to create a component called error item. Now inside this component, we can set it up just like a standard component. So I'll import React from React. Then I'll import view, text, and style sheet from React Native. I'm also going to import feather from @expo icons. So now we can declare the component. I say const error item equals, then I use a set of parentheses, an arrow, and some curly braces. I'll make sure the component is exported, so at the bottom of the file I say export default error item. Before the export, I also need to set up the style sheet. So I say const styles equals style sheet dot create, and I'll pass in an object here. Inside the component, I'll say return, and then I'll add a view and some text. Inside the text, I'll pass in the message, sorry, something went wrong. Next, I'm going to add a feather icon. So I'll say feather, and then I'll set name to frown, size to 100, and colour to white. So let's set up the styles. On the view, I'll say style equals styles dot container. On the text, I'll say style equals styles dot error message. Then inside the style sheet, I'll set container, and I'll say flex of 1, background colour of red, justify content of centre, and align items of centre. And then for the text, I'll say font size of 30, colour of white, margin horizontal of 10, and text align of centre. Now let's test this out. In the app.js file, we can start by importing error item from components error item. Next, in the render with the activity indicator, we can use a conditional and say if loading, then return the activity indicator. Otherwise, return the error item. To test this, I'm going to go to the useGetWeather hook. At the bottom of the hook, where we return the values, I'll say true for the error, and I'll add an empty array for the weather. This just means we now have the state set up in order to test out our error item. So let's save this and see how it looks in the simulator. When the simulator runs, I see the error screen that the user would see if something went wrong when the location and weather are being set. Let's go back to our hook file and revert the changes we just made so we set the error and weather back in the values returned by the hook. So now let's go through our app screen by screen and check if there's any other refactoring we need to do. When I look at the current weather screen, I can see we need to add the degree symbol to the initial temperature value. I also want to slightly decrease the font size in the description and message. So let's do that now. Back in the component, I'll add the degree symbol to the temperature. Then in the style sheet, I'm going to remove the pink background colour, as this is now not needed. Then I'm going to set the description font size to be 43, and the message font size to be 25. I'm lastly going to add optional chaining in the places that we are accessing nested object properties. This means undefined will be returned if one of the properties does not exist instead of an error. Next, let's take a look at the upcoming weather screen. As we're using white text, I think the background colour of the list items is slightly light, so let's update that. Let's go back to the list item component. I'm going to set item background colour to be Indian red. This is all one word and all lowercase. Lastly, I'll add optional chaining where we're using the weather type. Everything looks a bit better in the simulator now. So let's take a look at the city screen. Everything on this screen now looks good to go. So we're ready to move on to making the final touches to our application. The last thing I want to do on our app is adjust the app component very slightly. I want to change the conditional to show the error item if the error state is true, and then otherwise show the loading screen. This just ensures that the user really does only see the error screen when there is an error. So I'll say if error, then show error item. Otherwise, show the activity indicator. So that is everything done, and our app is now complete. Before I wrap up this course, there's a couple of last topics I'd like to introduce you to, but you can consider this as bonus material. The first one of these topics is the Context API. You may have noticed when I implemented the tab screens as children that the documentation said that it advised you use the Context API. The reason I did not do this is because we only have 3 core screens on the app. However, if you're in a position where you're passing the data around a lot of components who are very far away in the component tree, and also perhaps if the state is complex, then the Context API is very handy to know about. It's also really useful if you have some global data which is needed throughout the application, such as a user's name or some theming for the application. By using the Context API, all the logic can become centralized. It's not specifically the right or wrong approach, it very much depends on your use case, and it becomes a slightly different way of handling your data instead of props. So you can share anything through the context, and once we share the data, the component can ask the context for the bits of data it needs. It's important not to overuse context, and definitely don't think of it as a replacement to props. But it's an approach that it's worth knowing about for when you need to access specific pieces of global data throughout the application. The documentation about context is here, but essentially there are 3 steps to creating context. You need to start by importing the context. Then you would define your context. So if you had a room context, you'd say const room context, and you'd set this equal to create context. Then you wrap the context around your components, and at this point your components can access the context. The last couple of topics I wanted to cover are UI-based topics. We haven't had the need in our application to create a button, although we have seen how the React Native button component works. Did you notice how this didn't really look like a button that you might have expected? Another common task when you're developing applications that you may encounter is creating custom buttons. React Native has a set of touchable components which help us with this. If we take a look at touchable opacity, we can see that it's a wrapper for responding to touches. Alternatively, we have touchable without feedback, but this doesn't give us a visual response, so this is likely not what you want to use when you're creating a button. In the demonstration directory that I created earlier, I'm going to go ahead and implement a button just so that you're familiar with how to achieve this. And then I'll start by setting up the component. So I'll import React from React. Then I'll import View, touchable opacity, and text from React Native. Next, I'll set up the component. So I say const r_button equals, and then a set of parentheses, an arrow, and some curly braces. I'll then export the component. So I just say export default, r_button. Next, I'll set up the style sheet. So I say const styles equals style sheet dot create. Into this, I pass in an object. So next, in the component, I say return. And then I'm going to use touchable opacity. And inside this, some text. For the text, I'll just say hello. Then on the touchable opacity, we pass in onPress. And we'll set some styles. So we say style equals styles dot container. We'll also set some styles for the text. So I say style equals styles dot button text. In the style sheet, I'll add these styles. So I'll start with the container. I set elevation to 8. This sets the elevation of the item on Android only. Next, I say background colour of blue. Border radius 10. And I'll set padding to 5. Then for the button text, I'll set font size to 15. Colour to white. And align self to centre. Then on the touchable opacity, we set an onPress prop. So let's set this up. We use this to define what we want to happen when the user presses the button. So I'll set up an arrow function called onPress. And inside this, I'll add a console log, which just prints out press. To test this out, let's go to the app component. I'll comment out the navigation container render. And then I'm going to import the button. So I say import r_button from demonstration r_button. Then I'll add this to the render before the activity indicator. Let's test this out in the simulator. When the simulator runs, I get to see the button. If I open the console, I can see the press is printed out every time that I press the button. I strongly advise you spend some time playing about with all the core components in React Native, as there's a lot you can achieve. You can look at modals for alerts, text input for text input fields, and the switch component acts like a toggle.